Welcome, everybody. Today is the 14th of January on Saturday. This is Dallas Personal Robotics Group monthly meeting. And this month got off to a little rocky start with the which online sharing service to use. Sorry about that. But I think we're going in good enough shape now. So if we could, what we're going to do is hear from Iron Rain, our favorite team, in first, and see what's progressed since December. And I see Doug joining on the Zoom, so I'm going to get in touch with him and get him to come over and join us. But I think we can just get going, and Doug will be here shortly. So with that, all right. Let me see. Doug.
Anyway, here we go.
Okay, so hi, we're Iron Rain. Team 6832. I'm Inuyo.
Oh, I'm Gabriel.
I'm Leo.
I'm Trey.
I'm Vance.
And we're gonna go ahead and get started here. We have a short presentation.
Just to help us guide this conversation. It's not linked, Gabriel. You have to hit present.
All right.
And we have Doug on board now, so this is good. So, and we got your presentation coming up.
Yep. So first, we're going to start with the assembled parts / subsystems. So first off, we have new wheels. Now, you're probably asking why new wheels over like the stock parts you can get. Well, there wasn't enough space on the stock parts. The new wheels allow for more grip, as you can see. And with a stock part, you kind of have to adapt to it. But with our own custom wheel, we can sort of configure that however we choose. You can see let me get it going. See the wheel. All right. So, next up.
Yeah, so since last time, we've made a couple modifications to the chassis. You can see that we finished the model for the underarm. So basically, it's just a double jointed arm. It's made of carbon fiber. So it kind of just like hides under our main arm, and we just retract on some sides, so we can pick up cones easier. So the reason we did this was mostly because of driver control. When we're trying to play from really far away, the third is not precise enough, and it takes too long. So by having the secondary arm, we can kind of make like a transfer, and just make the whole process faster. So we've actually gone on to build that, but we'll talk about the gripper first. It's supposed to be a way to pick up the cones without having to focus on like getting right in front of them. So basically, that ring that you see coming out of the glass hood, it's like our swap zone. So anywhere in there, we can kind of just land on a cone and pick it up. So it kind of cinches around the cone. So it kind of cinches around the edge of this cone, and that's how we pick it up. And it's supposed to mesh with our bulb gripper, so we can like transfer it. But yeah, we actually built that over the break last time, so I guess we're gonna demo that, right? So if you want to move the camera over here, guys. Gabriel, you wanna hold this for me? All right. So this is the underarm. You can see the double jointed arm. Oh, that's not good. Okay, so kind of just extend out, and the whole thing is on a miniature turret, so we can kind of control the angle of approach, and this little lasso gripper is just on a pivot, not really controlled by anything. But I guess you can drive it real quick. So right there is the net position, and yep, I have very little drive practice with this, so bear with me here. I guess you can see that's the lasso gripper opening and closing. Yep, maybe. Possibly. Maybe.
That's the most it goes. You went past the limit.
Okay, there we go. It's a code thing. Yeah, it opens and closes, and we're supposed to like land on the cone as such, and close around it. And now we go for a transfer. I guess that would work. Okay, there we go. And it's supposed to pass through itself. So you can see it does that. And here's where we'd have the transfer with our main arm. So I think we just release. Yeah, that's kind of how it works. And I said it holds under the robot. So when it's powered off, it's going to go kind of like that. And, below this, it's not built yet, but the cherry assembly is what we called it. We want to slide back to the previous slide. That motor assembly with the mechanism is what actually drives the whole underarm assembly away from the main base. So yeah, that's kind of how it works. Yep. Any questions so far? Maybe. No. All right, moving on.
Can you hear me? I guess you can.
Yeah, I can hear you, Doug.
Okay. Is this? This looks pretty cool. Is it not? You're not using it on your main arm?
I'm sorry. Can you repeat the question?
Yes, if you were using it as your main arm.
Oh. So no, this is not the main arm. This is just this is basically our intake. So it's if you use a single arm, it just takes way too long because you have to worry about landing right on the cone, and the slop zone. And we can play from further out, which is kind of our strategy, but we don't have to drive at all. So instead of driving the whole chassis, we have this miniature robot, I guess, to do most of the work for us, and we can just worry about scoring. So
Is the miniature actually separate? Are you essentially sending out minions, or do you is it attached to the main robot somehow?
Could you back up to that picture that shows the whole context of the robot?
Yeah, I think that's what I need.
Yeah.
Right.
There we
so
go.
there's some linear slides that kind of attach to the bottom of the robot, and they kind of slide out as you drive away. That's how it remains attached to the main body. But
because it's against the rules, isn't it, to have mini robots, right?
Right, and this is not the complete model, by the way. It's just the chassis assembly, pretty much. But I guess, yeah, it's not the main body. It's supposed to drive away, so it could probably reach 2 tiles away with 4 feet probably. The main robot. And the arm, we get all the reach. We can probably play from halfway across the field and still be able to reach cones.
So
is this something that a competitor could just simply sit in front of you and prevent you from using this, and that kills your scoring?
Is this something you can prevent? Is this something another robot can prevent?
Well, usually we're going to play on our side of the field, and as long as we coordinate, it shouldn't be a problem. But when we worked with a single arm, we still kind of played similar. We'd have to stretch across a big amount of space, and so we haven't had any collisions yet. So we're kind of hoping our teamwork kind of fixes that or prevents that from happening, I guess.
So
the question I had is can an opponent shut your scoring completely down. I mean,
So if this doesn't work, right? Or
No, can the opponent block us from scoring with the second arm?
this is purely intake, so this isn't going to be for scoring. That's what the main arm is for. But
this feeds your main arm, right?
Can an opponent basically block the substation, preventing you from picking anything up?
well, I don't think they can, right? Or well, I mean they could, but they'd get a penalty for it. But yes, if they block the substation, we
Well,
wouldn't
it
be able
wouldn't
to.
necessarily be considered interference. I mean, he's not. It's not like he's not. Just he's knocking you or doing anything. He's just standing there.
Oh yeah,
There's a rule against blocking access to the substation.
Yeah, I guess there's a rule against that, so they would get a penalty for doing that.
Okay, good.
So just to be clear, so do I understand then that this is essentially the whole base, that if this is the intake that you're showing with this underarm chariot, will the output or whatever be also attached to this base?
Yeah, so on the bigger plate, we're gonna have our main turret. So I'm not sure if we have, or actually we're gonna go through the models later.
Yeah.
Later, okay, that's cool. But just for now, so so what we got started on, because we have people coming in a little bit late. So this is the robot that Iron Rain you've presented then so far, and then we've talked so far mainly about this arm to the right, and that's what you've been talking about, right? Yeah, that one right there.
So
okay, thank you. That answers my question.
Yeah.
Okay.
I had a question about the drives on the different joints of the arm and the wheels. Are those are you using gears or belt sprockets?
Kind of direct drive. So inside of this like little housing, there's a bearing, which is what holds the load, the arm. So the servo is just like, well, there's a servo horn here too, and that attaches to the arm. That's what actually applies the power, if that makes sense. So
sorry, can you say that again? I was
right. So in this like house, there's like a bearing assembly, and there's a servo horn as well. So the bearing takes care of like the actual weight of the actual arm, and the servo horn applies rotation. So we don't really need any big gears or sprockets or anything to move this.
okay. So it's directly connected. The servo is directly connected to the arm then, or the output of the servo. Do you have issues with that stripping or?
Not really. These are some pretty fancy servos. So if you want to talk about that, they're from Axon Robotics. They have like a titanium gearbox, and they're not actually holding the weight, so there's not too much stress. And since we're going to be playing relatively low, and we only intend to pass through ourselves, the torque shouldn't be anything that they can't handle. So yeah, I can actually demo it again. Like,
oh, that's okay. I was just kind of curious how you drove, but on the wheels, you're using basically sprockets for belts, right?
yes.
On the red drive wheels.
Yes, on the red drive wheels. So that's mostly a spacing thing. So I guess Gabriel talked about this earlier, but the original wheels on the first robot were just too wide, and I mean the robot collided with these like these holes, which kind of screwed up our driving. So yeah, there should be a sprocket that attaches to this like plate and a pulley. Sorry, I'm blanking, but there should be a pulley that attaches to this plate, and I mean this makes it more reliable because the chains on the old robot tend to pop sometimes, and they get very loose over time, and that's just not good. So pulley should be more reliable for us, and that's why we decided to go with it.
I'm sorry, and that's why what?
Yeah.
Not verified yet.
Well,
The theory.
in theory, the pulley should be more reliable for us, and they're also slimmer, so they make the robot thinner overall, which is a plus.
Okay. Hmm.
Yep.
So you haven't had any issues with either like belts popping off or, um, you know, skipping across
Uh,
teeth on the
okay, well, it's
sprockets or
not actually
anything?
built yet, but in theory,
Oh, okay. Okay.
What tooth profile are y'all hoping to use on the wheels there? Like 3mm or 5?
I'm sorry, can you repeat that?
Are y'all trying to use 3mm tooth profiles or 5mm tooth profiles?
2 millimeters.
Okay.
But we distance it so that it should be like perfectly tensioned, so the flipping should be minimal, if at all. Yeah. Yep.
All right, if that's all for
Cool.
questions, can I move on to a CAD walkthrough, basically, of what is yet to be built?
Okay.
So,
Are you out of it?
so we're gonna get that set up real quick.
All right.
Just have an untitled file open. Where do you want to start? Which file do you want to have?
We gotta do all of it.
Start with just reference.
Start with what's first.
Okay. We see the whole robot now on the field.
Yep, so we've stopped sharing on this computer over there, and we're going to switch over to another computer that we have Fusion 360 on. And we're just
All right.
going to showcase some of the models that we're working on that haven't been built yet. And that hopefully that'll give you a better idea of what we're shooting for and what's to change with the robot that's on our camera right now.
Cool.
What? You're doing
Yeah.
Why?
Hi, can you hear us?
Yes. Sounds good.
Yes.
All right, we're just gonna wait a few more moments before we get started.
And I'm gonna I want to suggest that we as an audience that we kind of gather our questions for a little bit instead of and try and let the team go through their talk a little bit, and then maybe not save all the questions for the end, but maybe not jump in too often. Unless Iron Rain, unless you want the questions as they surface.
All right, so what you see here is our shoulder and turret assembly. So this is what is going to be on top of what we were talking about earlier, on top of the chassis and the underarms. So here, all right, so the changes that we have made or that we're currently working on making is that we will be using 2 motors for the shoulder drive instead of the motor that we were using initially. This is not the final design. We are currently planning on changing the alignment of the motors. And this also does not include our arm and the extension for that. This is a work in progress. And another change that we have implemented. Okay. So another change that we are implementing is this aluminum bridge, because we wanted to stop using the rev rails and include something with more strength. So we designed a aluminum bridge to mount these two motors, as you can see here. And this is our Lazy Susan. And like on our old design, we will be using this turret here to rotate the entire turret and shoulder system. And the arm would be attached here, but this is currently a work in progress as we figure out any kinks on the design and add more motors and additional parts of the design.
Could you point that out on the actual picture of the actual robot where that is?
This
I
hasn't
see.
this hasn't been added to the actual robot. Would you like to see the current version we're working with, which we will be changing on Talbot 2?
No, I guess where will this? Can you just point to where it will mount then?
It'll mount on a base which hasn't been CNC'd yet, because we're changing the entire base, which is what we'll talk about next.
Okay, so this is the
A replacement for this assembly here. Just rotating assembly.
Okay, got it.
And that model that you see doesn't include this arm. It's just the subsystem, this turntable subsystem. Yeah, so basically all we're showing is that we're changing the shoulder drive here to include two motors and the turret drive to also include two motors, which should make it more powerful. And yeah, still in CAD right now. That's why we're showing CAD.
And we're changing the design because we're thinking of adding a fourth stage to the arm that you see here, which Trey will now talk about. If you have any questions about this design, just ask now. And here is the fourth stage arm we're working with.
Okay. So one of the main reasons why we were changing the turret design and the shoulder to be more powerful is that we want to make this robot have a lot more reach so that it can grab cones from across the field and deposit them in completely different locations. So that's why we have the underarm, why it's on a chariot, and that's also why we're adding a fourth stage to the linear sidearm that's already on the robot that you can see on the camera, but on the camera it only has 3. So in this model, you can see that we've added a fourth one, and it's got a longer reach. And the other thing that we did to it is that we changed the linear slides here to be thinner, which should make it lighter while still enabling it to reach much further. So by making it lighter and by changing the shoulder design to include 2 motors, it should be able to effectively reach across the field and then deposit whatever the underarm grabs. What else have we changed? Oh, yeah. So I also want to present the chassis assembly here that you saw some pictures of in the presentation. So as you can see in the chassis assembly, we're switching to a carbon fiber base plate that should be a lot stronger than the current polycarbonate one, which is cracking under the pressure of all the screws that attach the turntable and the wheels. And here you can see the new wheels that we've already manufactured, and we're just finalizing a few things in this design before we can start manufacturing it. But it's very similar to the old one, just carbon fiber with a polycarbonate outer ring. And so that should help deflect the cones like we have in the current design. So not much is changing with that. I think the only other thing that we have to show is the underarm, right?
Oh, I guess so.
As soon as Leo comes over here.
Right, so I guess I'm gonna open this one. Waiting for it to load. Right, so this is the chassis and arm assembly that I showed earlier. And I guess we already talked about it, but I can show how it's supposed to slide out. So that's the turret. Right, so it's on 2 linear slides, so it drives up pretty far. And with the arm being able to articulate too, you can see that we're gonna have a lot of range. So now imagine the 4 linear slide arm in the other direction, and we can reach pretty much anything on the field now. And yeah, it helps balance out the weight of the arm too. It's if you guys remember from last time how much of an issue we have with tipping, this is also a solution to that. I guess I can show the turret, right? So this little arm is also on a turret. And we made an odd design choice to include the battery inside the moving section, mostly to add more weight or more resistance so that tipping isn't as big of an issue. But yeah, that's about it. If you guys have any questions.
Yeah, what drives your slides? You have a motor on.
Right, so you can see like in this little chariot assembly, there's this motor with omni wheels.
Yep.
So when it's folded in, if I can do that. Right, when it's folded in and meshed in with the main body, all these wheels are going to be touching the ground.
Yep.
So we just drive away, and that's how it extends.
Oh, okay. So you just have two. So the rails aren't driven; it's driven by the wheels on those 2 motors.
Yeah.
Yeah. Okay.
Yep.
That's cool. So what?
Okay.
I had a question about the other part. The arm that had 4 sections. What extends those sections out?
Sorry, can you repeat the question?
Okay, you showed an arm that had like 4 sections to it.
Yes.
What extends those sections out? Is there a motor at each? Do you have like a rack and pinion on each joint, or?
So if we can point the camera to the original robot, right now we have some belt. It's a belt system, and there's a motor at the base of these linear slides that turns the belt, which pulls the linear slide arm out. You can see Leo's doing a demo of that right now. So it's just one motor at the base. I'm not sure if you can see the belts in the camera, but you can see in this model we have the pulleys, and there's like 100 different ways to string up a motor and a set of belts to extend an arm, but we just picked one and it works pretty well.
Oh, okay.
So how will you transfer the cones from the intake arm to the placement arm and keep everything aligned right?
Yeah, that's a problem we haven't really touched on yet. I think what we decided on is we're gonna put like a split in the middle of this rod, and it's gonna bend backward, and then the transfer will just be automated in the code.
Yeah, we're thinking of including like a wrist into that cone grabbing assembly, so we can articulate it to the position we need to be at.
Sorry, that last audio was a little quiet.
Again.
Currently, both grippers are like, I guess, based on gravity, so they always point down. So we were thinking of adding a wrist to kind of articulate the main cone grippy thing where we need it to be.
Okay. So that's still a work in progress.
Yes.
Yeah, pretty much.
Boy, there's a lot of pieces going on right now.
Yeah, we have a tendency as a team to make things much too complicated, but that's kind of our favorite part of robotics is making things too complicated.
It's fun.
Yeah.
So a couple of questions have surfaced from we have Franklin here from team 22201. Franklin from team 22201, just getting started. This is her first year, and he was wondering what material are you using for the red wheels, and could you briefly touch on why did you choose the two-wheel design versus Mecanum?
So the tool wheel design, we like it because it's got increased traction. And it's also very similar to what you might see in the field. A lot of the robots that you see in actual industrial settings use regular wheels rather than mecanums because mecanums are built for perfect environments like the fields in the competition. So we really want to train ourselves to be able to do robotics in the real world after we graduate from this team. So that's one of the main reasons why we're using the wheels. But I guess the other one is traction. I suppose the fact that they look cool is a small reason. And there's a few other that aren't coming to mind at the moment. But I
Cool
promise
is
you
worth a
if
lot. I like points for cool. At least.
Are they Ninja Flex?
Yes, the wheels are Ninja Flex. These parts here that I'm pointing at, they're carbon fiber. And then we also have some white nylon pieces in here. If I can hide that plate, you can kind of see how it goes together. I think it's this one.
So I had heard Kareem had mentioned that y'all are still working on the carbon fiber. So I'm sensing you got carbon fiber in the wheels. And
Yep.
was that carbon fiber in the intake arm?
Yeah, the intake arm is almost completely carbon fiber.
And what's the process that you're using to cut that stuff?
So we just cut it on our CNC. We have a few specialized carbon fiber milling bits. And so any model that we make, we run it through the onboard CAM software on Fusion 360. And then we can upload the code that comes off of that software onto our CNC. And it's a little bit more difficult to work with than aluminum. We have to use gloves, masks, we have a vacuum. But once you have all the safety measures, it's actually a pretty easy material to work with.
Cool. And
If
then
that
is
answers
it
your
all
question.
bolted or do you use some of that fancy epoxy glue?
Bolted to what?
I mean, how do you do you ever join two pieces of the carbon fiber together, or do you just assemble the different components with bolts?
We always use bolts. We don't know. We try to stray away from glues and epoxies because they mean that we can't actually change our design or repair it. So everything that you see has been assembled with screws.
Okay.
I think we can do a demonstration of scoring patterns, which is our big code update, if I stop sharing and the other side of the team starts sharing, if
Oh, that
y'all
sounds
have no more
cool.
questions.
Any more questions, guys?
Nope.
All right,
Yes, live software demo is always cool. Yeah.
All right, here we go.
Yeah. So, so a few changes from last time have been we have Auton tuned a little bit better. I'll show you that now. Yeah. And so now we're gonna drop the first tone, and actually it's not gonna work. Why? It's supposed to pick up from the code stack and then put the code on the pole. But we have not had very much time to tune that part of the Auton. And part of the problem is our field is a little crowded. So the wall is actually so I'll let it run through its code stack and explain some of the downsides. So yeah.
Looks like you have one frustrated robot there. Can't get to the cones.
So that was Auton.
Yeah, that was Auton. And it parked in the right place. We have it set to park in the middle, so that's where it is now.
Are the
So,
cones that close to that wall normally, or?
yeah.
Oh, they are. Wow.
Yeah, they have to be touching the wall. And so that's another difficulty, is getting it reliable and so you don't hit the wall. And yeah. We have to get really close to the wall but not touch it. I mean, we can touch the wall, but it throws off the robot a little bit. So
Right now, the distance sensor is disabled, so this is pure odometry, but and inverse kinematics without sensing the actual cone position. So
yeah, so we have not gotten the distance sensor working yet. So one update from last time is core patterns. We actually have them coded and working. So I'll show that. So right now we're going to substation. And of course the robot tips over. Very fun.
We seem to have that effect on this robot. Sorry.
So I'm gonna set it, but I'll take 5 foot.
Trey, is it possible to zoom out that camera anymore so that it's not panning so much? It's like really laggy.
No, sorry, it's not.
Okay.
I wasn't expecting to have to use this camera today.
Right.
So I'll show the scoring patterns now, because that's something new and something that actually helps the drivers a lot. Yeah, sure. Yeah. Okay.
Oh, can you hold that pole so it doesn't crash into it? Big one. Okay, that's new. But you can see it goes to the substation.
So you guys see the part of our problem is the turret is really wobbly, like the side to side. So it's really hard for the driver to line up perfectly. So that's one thing we're planning on fixing the new model, is we're gonna have two motors controlling the turret instead of one, which will definitely help that. And so as you can see, it went to this pole. And if I coded it right, it should go to a different pole now automatically without the driver having to do anything.
See, it's autonomous.
Yeah. So it's a lot faster than having the driver manually drive the crane to the different poles and drop it. So and as you can see, it gets pretty close, but not perfect. So the driver still has to do it manually and line it up. Yeah, the driver has to do the last bit manually and then drop it. So it can't be fully automatic right now, but hopefully with the nudge stick and the distance sensor, we will be able to do it mostly automatically. Yeah. And so it's just running through the pattern. And yeah, 50 makes it so we get a lot of poles. We drop cones on a lot of poles, which gives us like control points. And oh, okay, the robot just broke.
What?
Oops.
Never seen that one before.
Yeah. Demo effect.
Yeah, demo effect for sure.
Yeah, a fully fell off.
And it
Look, how?
exploded. Oh my goodness.
Right here. Yeah. Very fun.
Yeah, that's literally never happened before.
Well,
What part of it broke?
Not the pulley falling off.
oh no, but we did recently have a belt break on the extension, which took a lot of time to replace because we had to take apart the entire crane basically to replace that. This one should be a little bit easier, but this still takes some time.
I think that's it for the live demo then, since everything is broken.
Yeah. Let me see what I have to talk about besides.
I think you need to make it really clear, guys, that all of that motion was 100% automatic, with the exception of the fine tuning of the position right before pickup and right before deposit.
Yeah.
And again, for deposit, there was supposed to be the nudge stick, but they haven't had a chance to really work on that for its final automation yet. They've been working through the scoring patterns as a higher priority item.
Yeah. Well, the nudge stick will definitely, hopefully, we can pick up cones and deposit them automatically without having to have the drivers do anything. That's the ideal goal. But and it's possible. It's once we get that distance sensor and the nudge stick, it should be not easy, but not too hard.
It looks like you guys are a lot closer to that this month than even just a month ago. So this is some pretty awesome progress, really. I mean,
yeah, scoring patterns have been the biggest improvement, definitely, because so much easier for the drivers to drive now.
Do we explain what a scoring pattern is?
Yes, I'll explain that. So basically, the pattern is just an array of field positions that the robot targets, or the crane targets. So I think the first one is here, is this pole right here. And then once it drops successfully and the driver picks up another cone, it will go to a different pole and then a different pole each time. That's basically to like maximize the how many poles we control, which gives us a lot more points, basically.
Why does it give us more?
Because for each, yeah, and also each different pole that we control, I think it's 5 points, right? Yeah, 5 points, and that's not even including
Now
the
it's
actual
3. It's 3 points. It's 3 points for owning a pole, and basically that means you have the topmost cone on it at the end of the match. That's what control means. So you can have teams battling over a single pole, taking control of it back and forth. It's only a 3-point improvement, but if your opponents have a cone and then you top their cone, then that it ends up as a 6-point net towards your alliance. So it is an important strategic thing towards the end of the game to control as many of those junctions as possible and to retake them if your opponents are taking them.
Yeah, and that's not even including the points you get for actually scoring the cone. That's just for controlling the pole, which is so. It's on these high poles. If you control it and drop a cone, you basically get 11 points if you block the other alliance.
Okay, I have a question. Okay, it looked like your positioning was a set pattern. Is that correct? Otherwise, like you go from pole 1 to pole 3 to pole 5, back to 1, or whatever position you're doing.
Yeah.
So what happens if it would seem to me that you'd want your driver to be able to set the next pole that it should move to, so it would take your opponents into consideration. So for example, like you're on pole 1 and you might want to come back to pole 1 again, but your automatic program is going to move you to 3. and your opponent's there putting it on one, bump, bump, bump. So you might want to come back to one. So it would seem that what you would want is your driver to be able to select the next pole, not interfere with where you're doing, but select the next pole.
Yeah, so that we've thought about that, and we're planning to do that. There would be a separate, so we can have two drivers, and right now we're only using one. So there'd be a whole another driver just for like doing that added strategy to like our pole placements. So yeah, we're taking that into consideration definitely, because
Actually, you already have the ability to skip over and go backwards in the pattern. So the driver already has that ability. But what Vance is talking about is the ability to track what the opposing alliance is putting down, so that the robot can automatically go to a cone that you've marked as captured by the opponents.
Yeah,
you should also talk about how many scoring patterns you have, Vance.
So technically we have 8, but there's really 4, but there's 2 cone sources that we can choose from, so that brings it to 8. But we have basically 1 for each like field quadrant. So we have 1 for each like corner of the field, and so 1 for the right corner, right close corner, 1 for the right far left, and then close left. So pretty much 4, technically 8, and we can swap between any of them mid-match without having it mess up the robot. Any more questions about the scoring pattern?
I have a question outside of the scoring pattern, and I was noticing a little bit of audio feedback, and I think, I don't know, it might be the microphones and speakers there at Iron Rain location, but if we can move, whenever we're ready for a question beyond the scoring pattern.
I have one more to talk about.
Seems to be happening only on Trey's input.
Yeah.
It may be the room, so we're doing that. Is that it?
Well,
Is it better?
Oh, it's actually on you, Carl. It's coming. The feedback's coming from you, I think.
I think even when I'm muted, okay, if we just have Trey unmuted, I'm going to mute myself and then Trey say something. See if we have mute.
I'm on this microphone. Can you hear the feedback?
Yeah, so when only Trey is unmuted, there's feedback. So wherever it's coming in from, there's, I think, it's even happening when just Trey is speaking. I mean, and unmuted.
I didn't hear any feedback when you were muted, Carl.
Huh? Am I the only one hearing feedback?
I'm not hearing feedback.
Okay, then don't worry about it. Never mind. Sorry, maybe it's just local to my machine.
Well, it's whenever your mic is hot, like I'm hearing it right now on your screen.
Gabriel, is the crane? No. Is it fine? Just not yet. So there's one last thing I want to talk about code-wise, which is the speed port. But I won't be able to talk about that till the robot is ready. So is there any more add? Is there anything after this that we can?
Nope. We're going to Q&A after this.
So let's do questions now while the robot's being fixed.
How is the robot progressing? What happened there? Was it a spool from the extension?
Yeah. So one of the pulleys on the belt basically fell off while we were sending it, and so that caused the belt to untension, which basically broke the extension of the arm.
Is that the same one that broke last time?
Yeah. Well, no,
it's the same pulley.
No, it's actually the pulley on the crane. It's not the one that drives the extension. Yeah. It was right here-ish. Yeah. I think last time we actually had a belt break, like snap, if I remember right. And that was a pain to fix because we had to take apart basically this entire frame piece just to get a belt like looped through. Right?
That is another change in that the next version of the robot is moving up to the 3mm belts. This the belt system on the older robot is 2mm. Standard like small scale 3D printer type belts. And while they work really fast and low friction, they're not quite as strong as we need.
Nope, not ready yet.
Yeah, when that happens to me, I call it the loose nut on the wheel.
Thing, actually.
Carl, did you have a question?
Yeah. Okay. So I was wondering, not so much on the design, but itself, but more on the process. So could you briefly touch on how many people you have in your team, and with all of the complexity that's apparent, how do you in the design process with all those people, how do you keep it all organized and keep everybody on the same page?
So we have 7 people on our team, right? I think 4 on three. 3 people are on modeling, and so they have to communicate. We have a Discord, and they communicate through there, which like what tasks each people are doing. That's one of the great things.
On the modeling side of things, sorry, I'm a little tall, I have to crouch down. On the modeling side of things, we communicate mostly through Discord. We also have we use a software called Tick to keep track of who's doing what and what tasks there are still left to do. We also have design meetings every once in a while, and there are a lot of changes that need to be done. Like we had a design meeting two nights ago. Yeah, we just went through like Mr. B looked at the model and he pointed out a bunch of mistakes, and so we went through and looked at all of them, and we started making plans for what still needs to be done before our next competition, which will be next weekend. So it's a little bit of organized chaos, but we also have some organization software and communication software that we use.
Okay. So tools-wise, it's Discord, and then there was some other task thing?
Yeah, we use a software called Tick.
Tick. Okay. Is there any kind of project plan or it's just more like evolutionary discussion-oriented tasks? So you discuss and then you queue tasks, but you like draw out the whole steps in the process from A to B.
It depends. Yeah, we do it differently depending on what we're working on. A lot of the time people are updated on what needs to be done because we have weekly practice meetings and we meet during the week as well. So people kind of know what needs to happen, and we're all pretty experienced with modeling, so we don't really need to draw out the process as much.
I think he's talking a little bit about Gantt charts versus, sprints and scrum meetings and things like that. So do you lay out the entire season and, do a waterfall build, that kind of stuff, or are you just more doing weekly meetings, weekly status meetings, that kind of thing?
I think we do more weekly status.
That's okay. And then in terms of like, do you have like define configurations from one step to the other. It's just the current state uses these files, these software files, and these versions.
It's the current state. We don't have defined configurations. We do have like completed robots. Like we consider the robot that's on the field right now a completed robot, and then as we're designing the second one, that'll be, I suppose, as you might put it, a second configuration. And then in between that, it's just whatever state the models are in.
Okay.
They rely on Fusion for the design history, so they do take different. Each one of them takes responsibility for the updates in a given subsystem. I don't think you showed sort of like the organization of your Fusion environment so much, but they have a bunch of different subsystems and all of the individual components that they have to create for each subsystem in one place, and then the different assemblies are in another place, and they each take responsibility for a particular set of physical things that correspond to physical subsystems. And Fusion has a pretty complete like history timeline and version management type of thing built in these days. So I think that's mostly what they rely on.
Okay.
Yeah. If there's a problem with something that somebody has modeled, we can always roll back and fix it as well.
It's sort of like got built-in Git.
Yeah, it sounds that way. Okay.
Yeah.
So you use the Fusion tool to manage the files or databases, but then it sounds like you've got these design reviews and practice meetings where the group comes together. But then when it comes to like individual components, those tend to be owned by a person. And if the group decides that parts need to be changed, then is it so that that individual would make the change and then the group would review it afterwards?
Yeah, that's about it up.
Cool. Okay. Because it's not, I mean, it's not easy to have a bunch of people, so many people pulling something like this together. But so there's 3 on modeling, but 7 on the team. So what do the other 4 do?
Well, there's the 3 on modeling those are the people who know how to model very well. Everybody else, I think Gabriel does mostly build, like the physical prototyping. Spence does code, and then we have a couple other people on blogs. They write the portfolios that we send to competition. Yeah, that's all 17 members. We have 2 on blogs, 1 on physical builds, 1 on code, and then 3 on modeling, and then everybody kind of helps out with the other sub-teams. We don't all, like, one thing that we do. Like, I do modeling, but I also do physical prototyping. I also do writing and photography, and I manage social media. So we all have our fingers in all the different pots.
Cool. Thanks. I've always wondered that because it's impressive, really.
Mm-hmm. Thank you.
Well, did y'all have any questions for the DPRG group? Any specific things that you'd like some feedback on?
Gabriel, you look like you have a question. You're staring at me. No, you don't have a question? Leo wants to know if we did better than last time.
Let's ask. Everybody has their cameras off, but you should turn our cameras on and give the thumbs up, thumbs down. I mean, I would go like this. A lot better. Yeah. Thumbs up all around. Look at that. You guys
great.
Knew it can happen, but you guys are just pulling it together. It's pretty cool. Pretty darn cool. It's inspiring.
I do have one question. This is probably the way I think. I don't like things that go bouncy, bouncy, bouncy. Is there any way you can make it more rigid, more so that they don't bounce so much?
Are you talking about the arm?
Yeah.
Yeah, so that's what we're working on right now. That's why we added a second motor to the shoulder. And one of the reasons why we're showing it off in the models is, by adding a second motor to the build, we're going to have more control over how the arm moves, which will hopefully prevent it from bouncing. And then also the bouncing comes from PID tuning, which needs to be fixed. That's an ongoing problem.
Yeah, that's always ongoing. Yeah. Okay.
A lot of that bounce comes, it doesn't actually bounce when it's short, when the arm is short. It's only when it's super extended. And, there's just a lot of torque moment happening in the physics. And the motor is like right at the limit of its ability to even lift the arm with the cone when it's fully extended and it's completely horizontal. And so I think they already made one change where they increased the gearbox ratio to the maximum for that particular motor subsystem. But they're even thinking about an even slightly longer arm in the next version. So although it's going to be lighter, it's overall it's going to be probably more torque at the full extension, and so that's why that they're looking at that, doubling the amount of power that they have available with the addition of another motor.
Okay.
Is that fixed?
Yep. Now that the robot's working, there's one thing that I think is pretty cool that we did. It's actually with the PID on the shoulder. So most know what a PID is. It basically just brings the shoulder to the correct angle at the correct speed and time. So I'm gonna turn off the PID or the proportion, integral, and derivative. And so the PID is currently turned off right now. As you can see, it's still holding position. So we actually changed the PID to use one more term. It's called a feed forward term. And right now, it's basically calculating how much torque is on the arm and how much torque do we need to apply to the motor to keep the arm in position. So yeah, that's definitely helped with the bounciness a little bit. It also helps make it much more precise and accurate. And yeah, so it'll actually hold position. Yeah. So the PID is actually doing nothing. This is only it calculating how much torque it needs to apply to the motor to counteract the torque of the arm and gravity. Yeah.
So that's sort of like baseline power, and then the PID is just responsible for deviations from that. So it's almost like having a spring added to the system that is counteracting the gravity of the applied to the entire arm based on its current angle and extension. Right, and then the PID just does fine tuning to the final position, and that's made a big difference. One of the things that I think is hard for them to demo here is that last time they were demoing it, as you extended the arm further out to more distant targets, it would also tend to lower, so you didn't have a consistent height above each of the targets. And now their height is consistent regardless of the distance of the target.
Yeah,
and
so
it's
I can
that
actually
feed forward term that's helping that out.
So I'm gonna turn off the feed forward term right now, and what you should see is it should drop over time. If I actually turn it off right.
Feed forward when he moves it out. So you're saying you turn PID back on, but feed forward off?
Huh?
You turned off feed forward, but turned PID up back on?
Yeah. So if I did this right, yeah, feed forward off, and as you can see, it still holds position really well. But as soon as you try to go up, it wobbles and shakes, and it's not. And it also tips over. Ooh. Yeah, that's also something that a feed forward term helps with. It allowed us to decrease the amount of power the PID could output, and so it was all based off the feed forward term, and so that would cause the robot to tip a little bit less, but Yeah. Yep. Yep. I think that's it.
I had a question on the scoring, because I think that was one of the improvements here too, right? The scoring planning thing.
Yeah.
So, do you guys have an estimate or a target for how many points you intend to score?
Well, I haven't really.
That would be a no.
So not with the current design, not with the current pattern.
We don't know.
We haven't tested it really much.
We don't know.
In fact, I think I did the scoring pattern last night at like 10. Yeah. So we don't have any testing with the new one, but on the old one we got how many?
Like 8 or 9 at max. But that also, well, it takes less time to pick up a cone now, so it'd probably be the same amount of cones scored. So, but because of ownership, the amount of points that we actually get should be more.
A lot more.
Yep. So, yep.
Interesting. Okay. I mean, you've got so much together, it's hard to come up with questions that really stump you. So
Yeah. Is the scoring for the autonomous section set right after that or at the end of the contest? So
so you get double the points if you score during Auton. So if you score like here, you get 1 point during Auton, or you get however many points correspond to this poll. I think it's 2. And then 4 points during Auton, and then you get another 4 points for teleop because you technically scored this. So you get 8 points total, I think, if that answers the question.
There are some Auton points that are calculated right at the end of Auton, so that's like the parking points. Which position your robot ends up in, and there's like 20 points for that. And then, but yeah, the cones also count exactly what they would count during teleop, but then they get counted again at the end of teleop.
Yeah.
So it's effectively double for the cone scored.
Could I ask a possibly hard-hitting question?
Yep.
When's your next competition?
Next Saturday. Yep. 1 week.
And how much of the new robot have you gotten manufactured?
We have the underarm done somewhat.
Okay.
And one wheel. It's not going to be ready.
It's not.
What competition do y'all plan to have the new robot ready for?
Hopefully by the tournament 1 week after.
2 weeks from now.
2 weeks from now, hopefully.
And y'all have a plan to actually like get things done by a certain time?
Yeah. So we're coming in Tuesdays, right? Tuesdays to do some catting and machining, as well as Fridays and of course Saturdays.
All right.
Yeah.
And the rest of today.
We get this done, guys.
It's going to be really, really tight, man.
Yeah.
But it's like I think that they're now in a position which is pretty precarious. They're going to have to make a decision. Are they going to go with the new robot, but it's effectively going to be untested, right? Or are they going to like continue with the one that they've been working on, and it'll be better tested and proven in next week's meet, and but they're not going to be able to like present on what they're doing because you got to present on the robot you brought.
Yeah.
Yeah.
So,
I mean, going to
tough.
competition with untested robots is not foreign to us.
Yeah.
But
nothing like a little code on the day of, huh?
Yeah. Hopefully the code will actually be mostly the same, apart from 2 extra motors, right?
Yeah.
Yeah. And those are actually gonna piggyback off existing motors. So hopefully, besides tuning, it won't actually be that much different.
Yeah, the robot is pretty much
in theory. Of course, for the underarm, which I'll have to.
The underarm is totally different, right? Because that's yeah. There's precious little time to code that.
Yeah. So it's gonna be a long Thursday and Friday.
Yeah, we also have no choice with the new robot.
Yeah. And picking up will definitely be different because we're now going to use underarm. So yeah, drive and code and build have a lot to do. So pretty much everyone has a lot to do. Yeah.
My kid's band director would always say that sleep is optional. So there you go.
Yeah. Yeah. I feel that. No.
Well, very good. Well, cool. Well, I wish we could give you some more great advice or help, but it sounds like you're on a pretty good path. Just need time to execute it.
Mm-hmm.
And volunteers. Anybody want to get on the build team?
Yeah.
Super useful.
I got to go back to college.
Yeah, we'd have to up our game to be at the right level of skills.
Oh, you give too much credit.
Is there anything more we should cover on the ground then, or should we let these guys get back to their build sessions and give them a better chance to finish? Okay.
That'll work for us.
Yeah.
Well, guys, everybody, thanks again for joining. Really sorry about the rough start on the arrangements here, but you sailed through it, pulled it off. So thanks for the demo. Can't wait to see how the season goes.
Thank you for having us.
Yeah, thank you.
Hey, Kareem, did you see that link I put in about the swerve?
Oh no, that's the team. Look at that. That's the team.
There's a team photo. There you go.
Right
Put
there.
that on the thumbnail right there.
Yeah. Okay.